All right, because this is all about the dissociation of water. This is one of the interesting things about water. Water can do this. Water will dissociate. Like an ionic compound, it will come apart. Now, not to a great degree, but it will come apart. The water molecule, as it separates, will separate into an H plus ion, which is the acidic portion, and an OH minus ion, which is the basic portion. When that H plus comes in contact with a water molecule, it forms the H3O hydronium ion. Now, the interesting thing about this is something that you already know. The concentration of the hydronium ion, the H3O plus, is very, very small. So small that it is 1 times 10 to the negative 7th moles per liter. If you were to write that out, that would be a 0.6 zeros and then a 1. So 0.000001 moles of H plus ion in every 1 liter of water. Now, because this dissociates evenly for every 1 times 10 to the negative 7th moles per liter of hydronium ions, we're also going to get 1 times 10 to the negative 7th moles per liter of hydroxide ions. So they're balanced out. And if you know anything about acids and bases, is the acid portion will balance out the basic portion. And this is why water, pure water, has a pH of 7. pH has to do with the power of the hydrogen ion. So if you take those two things, the hydronium ion concentration and the hydroxide ion concentration, multiply them together, you add the exponents, you get 1 times 10 to the negative 14. Well, pH is the power of the hydrogen ion concentration. That is the power, which is 7 and the negative 7, the 1 times 10 to the negative 7. The 7 pure is the pH. The pH of pure water is 7. The pOH of pure water would be 7 as well, because that would be the power of the hydroxide ion concentration. pOH, pH, those two things, they have to add up to 14. So when we talk about acids and bases, we talk about acids having a pH less than 7, bases having a pH greater than 7. This is the reason why. If we have a concentration of hydrogen ion concentration, that will be less than 7. It'll be 1 times 10 to the negative 7, or 1 times 10 to the negative 6, or 1 times 10 to the negative 5. All of those would be acidic solutions. A basic solution would be a pH where the hydrogen ion concentration is less than the hydroxide ion concentration. Something like 1 times 10 to the negative 8. A pH of 8 would be a hydrogen ion concentration of 1 times 10 to the negative 8, but the pOH would be 1 times 10 to the negative 6, which would be larger than. So that's why a base has more hydroxides than hydronium ions, and an acid has more hydrogen ions or hydronium ions than hydroxide ions. The other term that's used in acids, bases, and salts is the term electrolyte. An electrolyte is a substance that conducts electricity when it's in the aqueous phase. We've talked about these before. The more electrolyte in the solution, the greater its conductivity. So if you have a strong acid which will completely dissociate, that would be a better electrolyte than a similar concentration of a weak acid, because the weak acid does not completely dissociate. Remember, ionic compounds, they are called salts. So to reinforce all this, I got a little homework for you, and here it is.